Good morning, good afternoon, and good evening. Ladies and gentlemen, 2020 was a year marked by the unprecedented challenges brought by the COVID-19 pandemic. It puts most things on pause, and the Shaw Prize Award presentation ceremony was no exception. But every challenge sows a seed of an opportunity. Today, I'm deeply honored to welcome you to the first ever virtual Shaw Prize Awards ceremony. I'm Leon Ko, the Master of Ceremonies again, for the presentation of this distinguished international award. Let me thank you all for attending this ceremony to witness the outstanding achievements of the 2020 Shaw Prize laureates. The Shaw Prize is an international award dedicated to honor individuals, regardless of race, nationality, gender, and religious belief, who have recently achieved significant breakthroughs in academic and scientific research or applications, and whose works have resulted in a positive and profound impact on mankind. This annual award is now held for the 17th year running. The Shaw Prize consists of 3 categories, namely the Shaw Prize in Astronomy, the Shaw Prize in Life Science and Medicine, as well as the Shaw Prize in Mathematical Sciences. Recipients of the prizes are all internationally acclaimed scholars and scientists. Each year, the selection committees and the board of adjudicators ensure that the highest standards of the selection and adjudication process laid down by the Shaw Prize are kept. To date, over 80 scientists have been awarded the Shaw Prize since its debut in 2004. Enabling a great many devoted and outstanding scientists to be recognized worldwide. For the 2020 Shaw Prize, nomination and judging commenced in September 2019. The results were announced at the press conference held on the 21st of May 2020, and there are 6 Shaw laureates this year. To begin with, I would now have the chairman of the Shaw Prize Foundation, Mr. Raymond Chan, to deliver a welcoming speech. Mr. Chan, please.
Welcome to the virtual 2020 Shaw Prize Award ceremony. Thank you for your patience. It has been an unprecedented year. Unpredictable is the word that comes to mind when reviewing the past year or so. But amid the uncertainties confronting us on a daily basis, we can find solace in the solidarity of science, as scientists around the world continue to demonstrate their resilience through the continued pursuit of their aims. Today, we extend a warm welcome to the Hong Kong Special Administrative Region's Chief Executive, Mrs. Carrie Lam, who remains committed to supporting global communication between the world's top scientists and our young aspiring achievers. It is a privilege to introduce and highlight the work of the Shaw Prize Foundation's distinguished team of adjudicators, whose diligence ensures the continued success of the Shaw Prize. The chairman of the board of adjudicators and each of the 3 selection committees are here today to enlighten us on the great contributions of the Shaw laureates in astronomy, life science and medicine, and mathematical sciences in 2020. Furthermore, we would like to give wholehearted recognition to our 6 2020 Shaw laureates, whose discoveries have significantly broadened the global knowledge in these 3 categories. Our special thanks to you for your patience and for your acceptance of the changed format of award presentation, as dictated by the pandemic. Although they were officially named as Shaw laureates on the 21st May last year, today's event marks the moment in which they will receive public acknowledgement of their achievements. When the COVID pandemic passes, we look forward to welcoming them all to the next live Shaw Prize Award ceremony in Hong Kong.
Thank you, Mr. Chan, for your speech. Today, we are much honored to have Mrs. Carrie Lam Chang Yut Ngo, Chief Executive of the Hong Kong Special Administrative Region of the People's Republic of China, to deliver her congratulatory speech. Mrs. Lam, please.
Raymond, Professor Shi, Shaw Laureates, past and present, ladies and gentlemen. I'm honored to have this opportunity to congratulate the 6 Shaw Laureates of 2020. COVID-19 may have delayed the presentation of the 2020 Shaw Prize. It has not, however, dimmed our delight in honoring the year's laureates and their profound achievements in life science and medicine, mathematical science, and astronomy. If anything, the pandemic has highlighted the critical importance of groundbreaking research and innovation in science and its numerous applications. It emphasized just how much we count on scientists' continuing pursuit of excellence. A case in point is the rapid development of effective COVID-19 vaccines, giving people all around the world hope for finally overcoming the pandemic. In the 14th Five-Year Plan of the nation recently released, we are delighted by the inclusion of the central government support for Hong Kong to develop an international innovation and technology hub. I believe this is a strong recognition of Hong Kong's strengths, particularly in basic research conducted in our universities, and the synergy in innovation and technology that is evident in the Guangdong, Hong Kong, Macau, Greater Bay Area. We will spare no effort in seizing these opportunities, and one of the key initiatives is a global STEM professorship scheme that will be launched later this year. By offering well-funded professorship and research support, the scheme aims to recruit overseas and mainland scientists to come to work in Hong Kong. Another initiative with planning underway is a Hong Kong Laureate Forum, organized with the full support of the Shaw Prize Foundation, which will take place towards the end of this year. Once again, my heartfelt congratulations to this year's Shaw Prize laureates for your remarkable efforts to create a better world through science. My gratitude as well to the Shaw Prize Foundation for its global vision and painstaking dedication in bringing that vision to life year after year. I look forward to seeing you all in person at the 2021 presentation. Thank you.
Thank you, Mrs. Lam, for your speech. Each year, the Shaw Prize receives numerous nominations from all around the globe. The winners from the nominations for each category are selected by the Board of Adjudicators, which receives proposals and recommendations submitted by the respective selection committees. It is now my pleasure to invite the chairman of the Board of Adjudicators, Professor Frank H. Hsu, to deliver his speech. Professor Hsu, please.
Welcome to the 17th Annual Shaw Prize Award Presentation Ceremony. In 2002, Sir Run Run Shaw and Mrs. Mona Shaw established the Shaw Prize to honor scientists in the fields of astronomy, life science and medicine, and the mathematical sciences. The inaugural award ceremony took place in 2004. In the ensuing years, the Shaw's entrepreneurship and philanthropy inspired the quest for new knowledge, highlighted outstanding achievements, and became a major force for progress in the world. The pandemic forced this year's Shaw Prize presentation to be a virtual ceremony, which the Shaw Prize Foundation, with its background in the film and communications industry, could undertake with confidence. Through modern methods of remote assembly, we are proud to be able to continue the founding vision of Mr. and Mrs. Shaw in promoting scientific discoveries whose beacons of truth and long-term utility only shine brighter in times of medical crisis, social division, and public doubt. This year, we honor 6 scientists in the 3 designated fields for their distinguished contributions. They are Professor Roger Blanford in astronomy, Professor Gerald Misenbach, Peter Hagemann, and Georg Nagel in life science and medicine, and Professors Alexander Bailenson and David Cashtan the mathematical sciences.
Thank you, Professor Xu, for your speech. Without any delay, let's begin with the first prize of today, the Shaw Prize in Astronomy 2020. I now invite the chairman of the selection committee for the Shaw Prize in Astronomy, Professor Reinhard Genzel, to speak on behalf of the committee. Professor Genzel is the director and scientific member at the Max Planck Institute for Extraterrestrial Physics and honorary professor at the Ludwig Maximilian University in Munich and professor in the Graduate School at the University of California, Berkeley. He was awarded the 2020 Nobel Prize in Physics. Professor Genzel, please.
In optical observations of the central galaxy of the Virgo galaxy cluster, the American astronomer Herb Curtis in 1918 noted a curious straight ray apparently connected with the nucleus by a thin line of matter. This measurement heralded the discovery of radiojets, the ejection of highly collimated relativistic plasma blobs from a central energy source. 40 years later, Caltech astronomer Martin Schmidt used the new 5-meter Palomar telescope to show that compact optical emission associated with the just previously discovered strange radio star 3C273 exhibited a remarkable 16% redshift of all of its spectral lines. If that redshift is due to the expansion of the universe, the distance to 3C273 must be 2.4 billion light years, and the optical luminosity of this galaxy is 1,000 times greater than the combined light of all stars in our Milky Way. This was the discovery of quasars, quasi-stellar radio sources. The 2020 Shaw Laureate in Astronomy, Professor Roger Blandford, has been one of the most important architects in constructing a detailed theoretical understanding of this quasar-jet phenomenon. In this model, most galaxy nuclei contain spinning massive black holes with masses ranging from 1 million to 10 billion times the mass of the Sun. When matter in form of gas or stars is gravitationally attracted by these black holes, a rapidly rotating hot plasma accretion disk forms around the hole just outside its event horizon and probably pervaded by strong magnetic fields. The interaction of the spinning black hole, the magnetic field lines anchored in the black hole and the inner accretion disk, and the extremely hot accretion disk plasma drive matter rapidly out along the rotation axis of hole and disk. Blandford originated key ideas allowing to understand the spectacular multi-scale acceleration and collimation of relativistic jets involving complex fluid dynamical and electrodynamical processes with Koenigsegg, Hagemann, Oestreicher, and Ries. With Znyák, Blandford proposed that magnetic torques could extract energy from the ergosphere of a spinning Kerr black hole and thus efficiently drive relativistic jets. This paper, as well as others on the creation of fast winds from accretion disks around black holes with Payne, Hagemann, and others, have in recent years become even more relevant and widely cited than when they originally were written. This is because high-resolution radio and infrared interferometric observations are just now beginning to directly probe the innermost accretion and jet formation zones around massive black holes, which Blandford analyzed in his prescient theoretical work. The disk winds are also relevant for outflows from protostars. Another paper that is now more cited than ever deals with the fate of binary black holes, which arise as the outcome of mergers between galaxies, with Hagemann and Ries. With McKee, he showed how time-variable line and continuum emission can be used to explore the spatial structure and broad line regions around active galactic nuclei. Blandford has made major contributions to an extremely broad spectrum of astrophysical problems, arguably placing him amongst a rare group of universal scientists. He has been one of the leaders in the modeling and interpretation of gravitational lensing. He has contributed to the interpretation of gamma-ray data from the Fermi spacecraft and to the study of gravitational waves. Blandford's contributions began and often are rooted in analytic work, but in recent papers he and his collaborators have exploited increasingly detailed numerical simulations to capture the complex physics in the strong gravity environment of spinning and accreting black holes. Blandford's many profound contributions to theoretical astrophysics and his continuing originality and towering presence make him a worthy recipient of the 2020 Shaw Prize in Astronomy.
Thank you, Professor Gansel. As proclaimed by Professor Gansel, the Shaw Prize in Astronomy 2020 goes to Professor Roger D. Blandford, Luke Blossom Professor in the School of Humanities and Sciences, and Professor of Physics and of Particle Physics and Astrophysics at Stanford University. May I now invite Professor Blandford to deliver his acceptance speech.
When I was notified that I had been awarded the 2020 Shaw Prize in Astronomy, my reaction was one of extreme surprise. This remains the case. However, my surprise was quickly joined by gratitude. I am grateful to Sir Run Shaw for his benevolence and wisdom in establishing these prizes. As I have learned more about him, I am struck by what a remarkable life he led. I am grateful to my colleagues who supported my nomination and humbled by the list of my predecessors, all of whom I admire greatly. I am thrilled to be included in their company. I'm also grateful to all the wonderful teachers, students and colleagues I have had over the years, and from whom I am still learning. In addition, I am grateful to my extended family, who have supported me in so many ways. Some of them came from Hong Kong, and I'm delighted that they can share my good fortune. My only regret is that the global tragedy of COVID-19, with all its consequences from the personal to the international, precludes our congregating in person. However, I am an optimist, and I strongly believe that I will have the opportunity to meet members of the Shaw Prize Foundation, fellow laureates, and my colleagues in person, in Hong Kong, in the fall. I look forward to this immensely. So it is with high expectation, deep appreciation, and unbounded wonder that I humbly accept the 2020 Shaw Prize in Astronomy.
Congratulations, Professor Blandford. Now comes the Shaw Prize in Life Science and Medicine 2020. I now invite the chairman of the selection committee for the Shaw Prize in Life Science and Medicine, Professor Randy Scheckman, to speak on behalf of the committee. Professor Scheckman is an investigator of the Howard Hughes Medical Institute and professor of cell and developmental biology at the University of California, Berkeley. He was awarded the 2013 Nobel Prize in Physiology or Medicine. Professor Scheckman, please.
Ladies and gentlemen, I'm pleased to introduce the 2020 Shaw Prize laureates in Life Science and Medicine, Garo Miesenbach, Peter Hagemann, and Georg Nagel. Luigi Galvani, in the late 18th century, was the first to appreciate that nerve cells could use electrical signals to pass information. Fast forward to the 1930s, when a brain surgeon, Wilder Penfield, seeking to understand the origins of epilepsy, probed regions of the brain with an electrode to find that the stimulation of specific areas elicited reproducible motor activities shared by all of his patients. Thus, the origins of a brain map. In more recent years, electrical stimulation of very specific regions of the brain has been used for therapeutic treatments, such as in the control of motor dysfunction in Parkinson's disease. Given the complexity of the human brain with around 86 billion nerve cells, each of which may make as many as 10,000 connections, totaling over 1 trillion or 10 to the 12th contacts, the task of a complete understanding seemed a distant prospect. And yet now, through the combined studies of our 2020 Shaw Laureates, Gero Miesenbach, Peter Hagemann, and Georg Nagel, we have a new optical tool and an approach using directed gene manipulation to map the circuits of virtually any neural network. Miesenbach was the first to appreciate the power of an optical probe to elicit an electrical response from targeted nerve cells. His team used the visual pigment rhodopsin, responsible for converting light into electrical signals transported to our brain, to engineer an artificial signal into nerve cells growing in the laboratory. His lab's particular application was to use the fruit fly rhodopsin, responsible in the fly for detection of light with as little as one single photon, able to elicit a controlled response in a single cell. They showed that a fruit fly rhodopsin introduced into a vertebrate nerve cell incubated in the laboratory could be stimulated by light, and further, that the use of this fruit fly rhodopsin could be used with the application of light to control a neurocircuit in the fly itself. The origins of the current revolution in optogenetic control of neural networks can be traced to the introduction of his 2002 paper, where Miesenbach concludes that, quote, since sensitivity to light is built into each target neuron, advanced knowledge of the spatial coordinates is unnecessary. Large numbers of neurons can be addressed simultaneously and precisely without undesirable crosstalk to neighboring cells that are functionally distinct. Now, rhodopsin from more evolved multicellular organisms, such as us, requires a set of other protein molecules and a small time lag to elicit a signal in response to light. For applications in neural network mapping, a faster and simpler light-responsive protein was sought. Years before the Miesenbach invention, and working quite independently, Peter Hagemann found a speedy photoresponsive channel rhodopsin, a class of rhodopsins that is also an ion channel and differs from visual rhodopsin, which acts only indirectly to open an ion channel. This channel rhodopsin orients a photosynthetic microorganism called Chlamydomonas to swim toward a source of light. Shortly thereafter, and again working independently, Georg Nagel found that microbial rhodopsins could be transferred by cloning into vertebrate cells where light would directly elicit a flow of ions. Here now was another key breakthrough in the development of the optogenetic tool. A single protein with a built-in light sensor triggering the opening of a current-generating channel. In 2002 and 2003, Nagel and Hagemann published two critical reports of channel rhodopsins 1 and 2, the second of which, found by Nagel, elicited an extremely fast light-induced increase in ion entry into cells to generate the kind of membrane depolarization needed to excite neurons. Within 5 years, the idea and specific application of channel rhodopsin 2 led numerous groups around the world to create ever more powerful approaches to the optical control of neural circuits. In an understated retrospective review, Hagemann and Nagel expressed some mild surprise that, quote, "We did not expect the research on molecular mechanisms of algal phototaxis or archaeal light-driven ion transport to interest readers of a medical journal when we conceived and performed our experiments a decade ago." But as we've seen repeatedly in these Shaw Award ceremonies, the power of basic science to reveal the rules of nature and their application to the human condition is perhaps the greatest invention of mankind. Thank you.
Thank you, Professor Scheckman. The Shaw Prize in Life Science and Medicine 2020 is shared equally by three recipients: Professor Gero Miesenberg, Professor Peter Hagemann, and Professor Georg Nagel. Firstly, I would like to invite Professor Gero Miesenberg, Wainfleet Professor of Physiology and Director of the Center for Neural Circuits and Behavior at the University of Oxford, to deliver his acceptance speech. Professor Miesenberg, please.
Receiving the Shaw Prize is a great honor and a great delight, for which I'm deeply grateful. This pandemic year has certainly put the spotlight on biomedical research. But especially when a practical problem needs an urgent solution, it's important that we keep a long-term view. The most valuable research is almost always open-ended and unpredictable, and it may even seem useless at first sight. The usefulness of useless knowledge is probably the most widely misunderstood aspect of science. Misunderstood by the tax-paying public, by governments, by funding bodies and philanthropists, and even by many scientists who too often ask, what is it good for? It is to the great credit of Run Shaw that he knew the value of fundamental research when he endowed awards in areas such as mathematics and astrophysics. And it is to the credit of the selection committee in life sciences and medicine that they have consistently recognized basic discoveries rather than medical advances, and that they have exposed the intellectual roots of these discoveries through painstaking scholarship. This year is no exception. I'm happy to share the Shaw Prize for the development of optogenetics with Peter and Georg. My portion of the work being honored was done by a small group of people in a small lab when I was just starting out as an assistant professor more than 20 years ago. Methods development is tough because there's only one acceptable answer. It works. Boris Sendelman, the postdoc who first used the biological light sensor to dictate electrical messages to a brain cell, and Susanna Lima, the graduate student who first remote controlled the actions of an animal in this new way, certainly had the necessary fortitude. And so did my young family, my wife Barry and my daughter Elizabeth, who didn't see much of me then and had to endure the occasional period of doubt or despondency when they did. Today, though, is a day of pure joy, for which I thank you.
Congratulations, Professor Miesenberg. May I now invite Professor Peter Hagemann, Hertie Professor for Neuroscience and Head of Department for Biophysics at the Humboldt University of Berlin, Germany, to deliver his acceptance speech. Professor Hagemann, please.
Dear Mr. Chairman, Frank Shu, Raymond Chan, and Kenneth Young. Dear members of the Shaw Foundation and members of the Selection Committee. Ladies and gentlemen, to be selected as one of the Shaw Prize Laureates 2020 is a great privilege, honor and delight. And I'm very grateful to the members of the Foundation and in particular to the Selection Committee. To receive one of the most prestigious and definitely most important scientific honors of Asia is certainly something very special. Moreover, to share the prize with my close colleagues Gero Miesenberg and Georg Nagel and to stand in line with the amazing scientists that have received the Shaw Prize since 2004 is great honor and delight as well. But we should be humble, because we all know that a great number of excellent colleagues contributed to the development of the new research field of optogenetics and are not honored with us here. And this is certainly true for many other research fields as well. However, it is fascinating to see who has been selected during the past years. The selection committee has chosen already in the past those individuals who went off the main scientific track at a very early stage, and I feel honored to be one of them. The combination of biological discovery of things that have never been anticipated before, combined with subsequent biochemical engineering to create something that never existed before, are the two aspects of science that always fascinated me until today. Over the years, I had the privilege to work with great co-workers and collaborators that expressed their sometimes odd ideas and challenged me to remain flexible and open-minded. Only this support allowed me to work efficiently and with great pleasure. Therefore, my encouragement to all of you in the audience locally and at the most remote places is to keep this openness alive and hand it over to the next generation of scientists, cultural individuals, and politicians. The freedom to say whatever we think, often against the current knowledge or opinion, is, from my perspective, the most important stimulus to move science and our cultural societies forward. Many thanks again to all who contributed to the Shaw Foundation and to those who made this event possible.
Congratulations, Professor Hagemann. The third recipient of the Shaw Prize in Life Science and Medicine 2020 is Professor Georg Nagel, Professor for Molecular Plant Physiology at the University of Würzburg in Germany. May I now invite Professor Nagel to deliver his acceptance speech. Professor Nagel, please.
Dear Honorable Chief Executive, dear members of the Shaw Prize Council and Selection Committees, ladies and gentlemen. It is a great honor and my pleasure to accept the Shaw Prize Award in Life Science and Medicine. The email with the announcement came as a big surprise I could hardly believe. When I studied biology in Constance, I was not thinking about prizes. I remember to be interested in the origin of life and if biology could address medical problems like my own. Whereas not further pursuing this interest, I was quite lucky that I encountered already in my first year Ernst Bamberg, who tutored in my biophysics course and then gave me the chance to work in his lab. To observe the activity of single-channel molecules in an artificial membrane was fascinating. Then he worked with bacteriorhodopsin from a microbe and demonstrated light-activated electrical currents. This led seamlessly to later studies on the sodium-potassium ATPase, where UV light liberated ATP from caged ATP. For my PhD thesis, I could participate in these studies. 5 important years in the US as postdoc followed, and I'm grateful to my postdoc advisors, especially the late David Gatsby at Rockefeller University, as well as Don Hilgemann at UT Dallas, for further instilling the joy of doing research. Most importantly, I met there my wife, Anna Maria Musti, who enjoyed New York with me, often on the bicycle. Later in Europe, she introduced me to molecular biology, very helpful for the cloning of channel rhodopsin, and then we raised together our wonderful daughter Nina. Back in Germany, it was again Ernst Bamberg who gave me the chance to proceed as group leader and convinced me to work on bacteriorhodopsin. Now, for the first time, we expressed it in vertebrate cells. Our study from 1995 could have been the beginning of optogenetics, but somehow it was too early. I'm grateful to Peter Hagemann for initiating a collaboration and providing the DNA he got from Japan for these special proteins from a green alga, which we call channel rhodopsins. Many neuroscientists then did wonderful studies with general rhodopsin 2. I would like to thank Alexander Gottschalk for generating the first light-controlled nematode with general rhodopsin 2. There are now many technicians, students and postdocs in my lab to whom I am most grateful, especially my former PhD student and now postdoc Xi-Chang Gao, whose input was most essential for our recent success with plant optogenetics. And I'm grateful to our host in the Physiology Institute, Manfred Hagemann. Last but not least, I would like to thank the Shaw Prize organization for selecting optogenetics and the selection committee to include myself to the awardees. Thank you.
Congratulations, Professor Nagel. Here comes the final prize, the Shaw Prize in Mathematical Sciences 2020. I would like to invite the chairman of the selection committee for the Shaw Prize in Mathematical Sciences, Professor Timothy Gowers, to deliver a speech on behalf of the committee. Professor Gowers is professor of the combinatorics at the Collège de France. Professor Gowers, please.
Alexander Beilinson and David Cashtan have had an influence on modern mathematics that is difficult to summarize in a few words, partly because they work in areas that require advanced mathematical terminology, but more importantly, because their influence has been extraordinarily broad, which means that I cannot mention more than a small fraction of it. A common thread to at least part of their work is the branch of mathematics known as representation theory, which is itself connected with group theory and symmetry. When most people think of symmetry, they think about symmetries of geometrical objects, such as rotations and reflections of triangles. However, the notion of symmetry is vastly more general than this. In the 19th century, when Galois was studying roots of polynomial equations, symmetry was fundamental to his investigations, and it became clear that symmetries had certain abstract properties that could be studied independently of any particular manifestation. This led to the formulation of the notion of a group. Groups are now one of the 3 or 4 basic algebraic structures that are taught in every university mathematics course in the world. Later, the process of abstraction was reversed. It turns out that one of the best ways of understanding an abstract group is to realize it as the group of symmetries of some object. If the symmetries are given by linear maps, then the resulting realization is called a representation of the group. Certain properties of the representations of a given group encode essential information about the group, so understanding what the representations are is an extremely important and in many cases very difficult problem. David Cashtan introduced a notion to representation theory called property T, which he used to solve 2 open problems concerning discrete subgroups of Lie groups. Property T has turned out to be a truly fundamental concept that has had applications to many areas of mathematics, and not just group theory and representation theory. He also formulated, with Georg Lustig, who won the Shaw Prize in 2014, 2 extremely influential conjectures that were solved by Alexander Beilinson and Joseph Bernstein. These breakthroughs led to the development of an area known as geometric representation theory, which adds a further twist to the story by showing that many of the structures that arise in representation theory can be understood in a different, more geometric way. The result is to convert several extremely difficult problems in representation theory into equivalent problems that are more tractable. This has led to the discovery of simpler and more conceptual proofs of existing results, and to the solutions of many problems that had hitherto seemed out of reach. The ideas of Alexander Beilinson and David Cashtan have had a huge effect on representation theory, and since representation theory is a fundamental tool in many other parts of mathematics and physics, from dynamical systems and operator algebras to the theory of networks, these ideas permeate a large fraction of mathematics today. They have not only proved wonderful theorems themselves, but they have developed tools that have allowed other mathematicians to do so as well. I and the rest of the selection committee for the mathematical sciences congratulate them for their remarkable mathematics and for the award of the 2020 Shaw Prize.
Thank you, Professor Gowers. The Shaw Prize in Mathematical Sciences 2020 is shared equally by two recipients, Professor Alexander Bailenson and Professor David Cashtan. Firstly, may I invite Professor Alexander Bailenson, David and Mary Winston Green University professor at the University of Chicago, to deliver his acceptance speech. Professor Bailenson, please.
Ladies and gentlemen, I'm deeply grateful to the Shaw Prize Foundation for a great honor of receiving 2020 prize in mathematical sciences. I was born in Moscow into a life that was not poisoned by wars and strife, nor by search for money and power. People were doing mathematics for the sole reason that it was extremely interesting. Among them were my teachers, Belavin, Bernstein, Drinfeld, Fagin, Gelfand, Mann, and Parshin, to whom I owe my gratitude for becoming a mathematician. Two features of math are prominent. Mathematics is simple. But to perceive this, your vision must not be rigid and fixed in one direction. Also, appreciation of math is virtually impossible without actively doing it. Like nature, it is reality you have to be a part of in order to see it. Remarkably, math shares these traits with our common life. It's dear to me that this prize comes from the country of Tao Te Ching. To me, understanding ourselves as tiny parts no more important than other living beings. Of the great flow of unknown is of key importance, both for everyone's normal life and for our common survival. And I'm so happy to share this prize with Cashtan, a dear friend whose works were at the base of a large part of my own research. Thank you.
Congratulations, Professor Bailenson. The other recipient of the Shaw Prize in Mathematical Sciences 2020 is Professor David Cashtan, Professor of Mathematics at the Hebrew University of Jerusalem, as well as Professor Emeritus at Harvard University. I now invite Professor Cashtan to deliver his acceptance speech. Professor Cashtan, please.
Mr. Raymond Chen, Professor Shu, members of the Shaw Prize Foundation and Selection Committee, ladies and gentlemen, it's a great honor for me and wonderful recognition of my research to be awarded the 2020 Shaw Prize in Mathematical Sciences. I am grateful for all the support the Shaw Prize Foundation provides for the development of sciences worldwide. On a personal level, I am deeply indebted to the memory of my grandfather, Peter Cashtan, who taught me the initial beauties of mathematics as we covered the mathematical high school curriculum when I was 12 years old, and to Israel Gelfand, who was my teacher and mentor for the initial 15 years of my studies. I am grateful to my life partner and wife, Helena, whose support made it possible for me to devote my time to research, and to my 4 children and 9 grandchildren. My various friends of multiple continents with whom I worked closely over the past 50 years have been a source of much joy. My professional life has been full of excitement and fulfillment, thanks to many bright and generous collaborators, with whom I had the fortune to discuss and develop new ideas and discoveries, while often sharing at the same time the happy events of our family life. I have been fortunate to have my professional and personal life always deeply intertwined. And finally, I am deeply indebted to Harvard University and Hebrew University for providing a perfect working environment and friendly atmosphere, so important for my work over the years.
Congratulations, Professor Cashtan. I would also like to extend my congratulations again to all laureates. As we draw to a close of the awards ceremony for 2020, may I invite Chairman of the Shaw Prize Council, Professor Kenneth Young, to give a message of heartfelt thanks to all joining us today. Professor Young, please.
As we bring this ceremony to a close, I wish to say a few words on behalf of the Shaw Prize Council, to thank everyone for joining the event in a virtual format. Even though we cannot meet physically in the same hall, our common purpose and values bring us together. We have gotten to know each other better, we have reaffirmed our shared ideals, and we have been inspired by the laureates' works and lives. We express our gratitude to Mrs. Carrie Lam, the Chief Executive, for her greetings and for her kind message. To all of you, thank you for joining us to honor the 2020 Shaw Laureates and to highlight their spectacular achievements. To these remarkable pioneers we say, thank you for your perseverance, for your determination to succeed, and for your continued drive to ensure a brighter future for humankind. And thank you for brightening up our lives today as we shared your joy and continue to bask in the afterglow of goodwill and camaraderie. For now, we say a fond farewell, with high hopes of welcoming you to our shores in a not-too-distant future.
Thank you, Professor Young, for your speech. Ladies and gentlemen, the Shaw Prize Awards ceremony 2020 has now come to a successful conclusion. Scientific research has embedded boundless possibilities. We look forward to seeing you in person and to witness more accomplishments of distinguished scientists and scholars. Please note that tomorrow, on the 21st of May, 3 Shaw lectures conducted by the respective Shaw Laureates 2020 will be hosted by universities in Hong Kong and delivered online at different time slots to facilitate participation. Please visit our website for the relevant information and links. An equally important announcement for all those who have been following on news about the Shaw Prize. The Shaw Laureates of 2021 will be announced at the press conference on the 1st of June 2021. Please stay tuned. Goodbye, and wish you all a healthy year.